Hi everybody. Want to go through this lesson on solving trig equations. I'll run through, and as we're looking through this, take time, pause, make sure you try things out, not just copy off the video. So here we go. So what we're gonna do now, just talking about some algebra skills for solving. Problem 1 is already factored. It's already broken down for you. So if something comes factored like this, we just solve each bubble. All right, so in this situation, x minus 3 equals 0, x equals 3. And this one, 2x plus 5 equals 0, x equals negative 5 over 2. I find with this problem, a lot of people FOIL it back together, and then to solve, you'd have to factor and break it down again. The second one, if we move over the 4x, so the equation instead equals 0, we can factor and solve. All right, so here we can GCF an x, which gives us x minus 4, which again, each piece equal to 0, gives us our two answers of 4 and 0. Last one, everything set equal to 0, x squared minus 3x minus 10 equals 0. Now, what two numbers multiply to negative 10 and add to negative 3? X minus 5, x plus 2, which means x equals 5 and x equals negative 2. Now, one more type of factoring to talk about. It's not on the sheet, but I know this will come up. So 2x squared minus 7x minus 4 equals 0. All right, splitting the middle term. So with splitting the middle term, we have a 2 in front. We don't have a 1 like the previous problem. For problem 3, since the leading coefficient there is 1, we just need to find two numbers that multiply negative 10 and add to negative 3. Not the case with a lead coefficient of 2. So it's split the middle term. 2 times negative 4 is negative 8. And the question is, what factors of negative 8 add to negative 7? Negative 8 and positive 1. So this is where we actually do separate that negative 7x. 2x squared plus 1x minus 8x minus 4. We group the front, we group the back. GCF an x leaves us with 2x plus 1. GCF a negative 4 leaves us with 2x plus 1. Right. If we don't get the exact same leftover bubble after we GCF, the problem is not done correctly or just isn't factorable. So since we get 2x plus 1 twice, that's great. So our final answer is x minus 4 and 2x plus 1. All right, so you have the GCF pieces making one answer, making one bubble and one factor, and then the leftover common one as the other, which tells us here that x equals 4 and x equals negative 1/2. All right, so there's the algebra review. Now we tie into what we're doing here. So having some basic problems. So if I were to solve for sine, I would add 1 divided by 2. Sine theta equals 1/2. Now this tells us that our answer here is between 0 and 360. So this is where we jump to our unit circle. Where on the unit circle is sine 1/2? Well, theta equals 30 degrees and theta equals 150 degrees. So we want to isolate the trig function. We want to isolate the sine, the cos, the tan, whatever it is, so that we can then use our unit circle. Example 2. Tan theta equals 1. Now the tough thing about tan is that tan's not on our unit circle. All right, 3, 2, 1, 3, 2, 1, all over 2. Rads. But we could add to it. So we know tan equals y over x. So down here, if we have 1/2 over rad 3 over 2, that's 1 over rad 3, which means that tan here is rad 3 over 3. In this situation, if we have y over x, same thing, rad 2 over 2 divided by rad 2 over 2 is 1. Well, up here, rad 3 over 2 over 1/2 gives us rad 3. So if it helps on your unit circle, add those tan pieces to it so that you could just quickly, easily get our answers. So what's theta in this problem? 45 degrees and 225 degrees. Now, are these the only answers? No. But since we have our answers saying between 0 and 360 degrees, they're the answers. Technically, right, if we added 360, 585 is also a correct answer that works, but since the domain is set for 0 to 360, we can't accept that as an answer here. All right, so we got sine theta equals negative rad 3 over 2. All right, so where does this work in this situation? I think ASTC. So sine's negative down here and down here. Rad 3 over 2, we're talking about 240 degrees. And we're talking about 300 degrees. All right, here we got cos theta equals 1 over rad 2, which is rad 2 over 2. Where's theta rad 2 over 2? We're talking about 45 degrees. And cos is also positive in the fourth quadrant, so 315 degrees. All right, now tying in our other trig functions. All right, we got sine, we got cos, we got tan. We also have cosecant, secant, and cotan. All right, so if I work with cosecant, I take the square root, I get positive negative 2. All right, well, what we know is that cosecant is the same thing as 1 over sine. So if we wanted to at this moment, we could write 1 over sine equals positive negative 2. Now, if I cross multiply, I get 1 equals positive negative 2 sine theta. So if I divide that over, sine theta equals positive negative 1/2. All right, that's important. So cosecant theta equals positive negative 2 is the same thing as sine theta equals positive negative 1/2. Now, I never really do this method. There's nothing wrong with this method, but what I know is just that it's a flip. So if I change this from sine, from cosecant to sine, 2 flips becomes positive negative 1/2. So where do we have a sine value of 1/2? We have it in every quadrant with a reference angle of 30 degrees. All right, awesome. All right, looking over here, any other different ones we should talk about? Let me go down to the cotans. All right, so cotan x equals negative 1 over rad 3, which if I rationalize is negative rad 3 over 3. All right. But I guess no, in this situation, we don't even need to rationalize. Why rationalize? If we got cotan equals that means tan, just by flipping it, is negative rad 3 over 1, which we don't have to write the negative, the 1 on the bottom. So tan x equals negative rad 3. All right, ASTC, third and fourth quadrant, that rad 3 is dealing with 60 degrees. X equals 120 degrees. X equals 300 degrees. All right, so again, I wanted to go over these flip ones. I feel like they help. So what do we got here? Secant squared x equals 2. Secant x equals positive negative rad 2. All right, so if I flip it, cos x equals positive negative 1 over rad 2. Positive negative rad 2 over 2. All right, so by flipping it, I'm able to then rationalize it so I can figure out my reference angle at 45 degrees. 45, 135, 225, and 315. All right, like I said, I wanted to hit on a few of these to make sure we're okay, but I feel like the ones up top we should be fine with. Now getting more complicated. All right, getting more complicated in this scenario. Tan squared minus tan theta equals 0. One thing that helps me is that I can say something like tan theta equals w. So I can make this w squared minus w equals 0. I like doing this because it gives me the visual of the algebra, not the trig. Well, how do I break this down now? GCF of W, so that tells me W equals 0 and W equals 1. So I changed it to an algebra problem, which tends to help me better visualize what's happening. Now once I have it broken down, let's bring back in tan. Tan x equals 0, tan x equals 1. So where does tan equal 0? At 180 degrees and at 360 degrees. Remember, y over x. Where does tan x equal 1? At 45 degrees and 225 degrees. So 4 answers in that scenario. So same thing as above. I'm going to say y, I'm going to go x. X equals cos theta. 2x squared minus 5x plus 2 equals 0. I got to split the middle term. 2 times 2 is 4. What factors of 4 add to negative 5? Negative 4, negative 1. 2x squared minus 1x minus 4x plus 2. Group. Take out an x. 2x minus 1. Take out negative 2. 2x minus 1. X minus 2. 2x minus 1. So x equals 2. X equals a half. Well, the problem is, cos equals 2, based off our unit circle, based off just a general cos graph, cos goes between negative 1 and 1. So this doesn't actually give us an answer. We got nothing that's going to give us a cos value of 2. But, on the other hand, cos x equals a half, this we could do. So where is the x value at half? We're talking about 60 degrees, and it's for cos. We're in the 4th quadrant. All right, example 8. All right, so again, I'm going to kind of x, y equals x. Big idea. Don't divide by x. If we do that, you lose answers. So if we divided by x right here, just talking about it, we'd get y equals 1. So we'd have sine x equals 1. That's what we would solve, which is great. But by dividing by x, we've missed out on some other answers. So what we always want to do is always factor. Right? Don't divide by x. We'll lose answers. We always want to factor. So if I make it xy minus x equals 0, if I GCF, now I got x equals 0, y minus 1 equals 0, x equals 0, y equals 1. So by doing this, I have some more answers in this situation. Cos x equals 0, sine x equals 1. Right? Where is cos 0? At 90 degrees and 270 degrees. Where is sine 1? At 90 degrees. So those are my answers. So if we didn't get the cos x equals 0, we would have lost out on the answer of 270. All right, so we got some practice on the next page. Let's look at one of the more complicated problems. So jumping down here. All right, so again, we can't divide by cosecant. We would lose some answers. So I can write this as secant x cosecant x minus 2 cosecant x equals 0. If I GCF for cosecant x, I'm left with secant x minus 2 equals 0. All right, so that tells us that cosecant x equals 0 and secant x equals 2. All right, so throw it over 1 because we got to flip these. So cosecant equals 0 over 1. I flip it, sine x equals 1 over 0, which is sine x equals undefined. Well, based off a sine curve, it's continuous in all directions. Sine is never undefined. This gives us no answers. I flip this, I get cos x equals a half. That is something manageable. Where is cos equal a half? At 60 degrees and 300 degrees. All right, so I hit on a lot of problems here. I didn't want to make the video too long to be too overwhelming. So you have the answer key, check things over, you have a homework to try out, and when I come back to class, we'll make sure everything's going okay.